Now as you can see on the left, we have a circle which is a sector. This is the minor sector, this is the major sector. We have a segment, the minor segment and the major segment. Now we're going to learn how to find their areas. So we'll start off with sector. There's a formula. You don't need to know the derivation of the formula, they won't ask it. If you're interested, you can go check out the textbook. However, I'll be teaching you the formula basically. So we know that the area of a normal circle, area of a circle is equal to pi r square. And what else do we know is that this angle, let's just call it theta. So this angle, we'll name it as theta. So the angle formed by two radius joining, we'll just call it theta. So the area of this sector, would be equal to theta by 360 into pi r square. That's the formula for the sector. And one more thing is, we know that the full central angle is 360 degrees. We know that this full thing is 360 degrees. So if this is 360 degrees and we want to find the area of a circle, so would theta also be 360? Would be 360 by 360 into pi r square. That's how you get the area of a circle, actually pi r square. And then the next thing is, so this is the area of a sector. So suppose they give you this time theta is 60. If they give you that theta, the central angle is 60 degrees, then the area of the sector would be 60 by 360 into pi r square. You'd get 60 by 360 into pi r square, which gives us 1 by 6. So therefore the area would be pi r square by 6. And then if they give you the radius, you could solve. So that's one way. And now they ask you to find the area of the major sector. There are two ways of doing. Two ways. One is the area of the major segment. The area of the major sector, area of capital M sector. Capital M means major. The area of the major sector would be equal to the area of the circle. Area of circle minus the area of the minor, small m, minor sector. It makes sense, Suppose you have, this is the circle and they want you to find this area. That's basically this circle minus this would give you this area. Otherwise, you can use the same formula except take the reverse. So we know that this full angle, this full thing is 360. So since the full circle is 360 and this is 60, that means the remaining would be 300. It makes sense, this full angle is supposed to be 360 and this is 60, so the remaining would be 300. So if you apply the formula, you get 300 by 360 into pi r square. I hope you understood this much. So the main formula is theta by 360 into pi r square. If you use it, you'd get your marks. If you draw the figure and you write the formula, you'll get 2 marks if it's a 4 marker. And now the next thing is area of a segment. We have the minor segment. So to find the area of a segment, you need to construct. What you'd want to do is, you want to make a sector. So keep a scale. Let this segment be AB. So now that you have AB, you want to find the shaded region, which is this. How you can do this is make a sector. Make a sector AOB. So this would be a sector. So now, if you can see, we'd get that the area of segment AOB, or area of minor segment, is equal to this sector, area of the sector, minus area of triangle AOB. We're basically saying that this segment's area is equal to this sector minus this triangle, and it makes sense. The sector has the segment and the triangle, so by removing the triangle, you'll be left with the segment. So basically this sector minus this triangle would give you the area of a segment. That's how you find it. So it would be theta by 360 into pi r square minus half into AB, and you'd need to construct a perpendicular. And then in the next video I'll show you how you can find this perpendicular's height into height OM. Let this point be M. So we get that theta by 316 into pi r square minus half into AB into OM. The next video I'll show you demonstrate a question where you require to find the height. You need to use a little bit of trigonometry. So that's all the important concepts for this chapter. Next video I'll show you some example questions.